Hello there, and welcome to a quiet corner of the cosmos where curiosity meets the chill of the unknown. I'm so glad you're here tonight, whether you're settling in for the evening, curling up somewhere comfortable, or simply letting your mind wander toward the stars. This is a gentle journey into some of the most mysterious and, yes, genuinely unsettling places that exist in our universe. Before we drift into the cosmic unknown together, I'd love to know where in the world you're listening from tonight. Are you gazing up at a clear sky, or perhaps tucked away indoors while the universe spins quietly overhead? There's something oddly comforting about contemplating the vast darkness from the safety of our little blue world. If you find these soft explorations through space and science soothing, I'd be ever so grateful if you gave this video a gentle like and perhaps subscribed. It helps other curious souls find their way here, and it means I can keep creating these peaceful voyages through the wonders and terrors that surround us. Now, I do hope this isn't so fascinating that it keeps you awake, though if it does, at least you'll drift off knowing a bit more about the strange architecture of existence itself. So settle in, let your breathing slow, and let's take a calm walk through some places in the universe that remind us just how small, how precious, and how beautifully isolated we really are. When we look up at the night sky, we see points of light scattered like scattered dreams across the darkness. Stars, planets, the gentle glow of distant galaxies. It's easy to imagine space as this grand theatre, filled with cosmic drama and celestial performances. But what if I told you that some of the most terrifying places in the universe aren't filled with violent explosions or raging storms, but with something far more unsettling? Nothing at all. Picture this. You're floating in a spaceship, drifting through what should be a busy neighborhood of the cosmos. But as you look around, you see emptiness. Not the comfortable emptiness between stars, but a void so vast and so complete that if you placed our entire galaxy somewhere in the middle of it, the nearest neighbor would be hundreds of millions of light years away. You would be utterly, cosmically alone. This isn't science fiction. This is the Bhuta's Void, and it's one of the most haunting places we've discovered in our universe. Sometimes called the Great Nothing, it's a region of space so empty it challenges everything we think we know about how the cosmos is supposed to work. The story begins in 1981 when an astronomer named Robert Kirshner and his team were conducting what's called a redshift survey. They were essentially mapping the three-dimensional structure of the universe, measuring how fast galaxies were moving away from us to understand where everything sits in the cosmic web. It's painstaking work, the kind that requires patience and an almost meditative attention to detail. Point your telescope here, measure the light, record the data, move on to the next patch of sky. But as they worked their way through the constellation Bhutas, something strange began to emerge from their measurements. Or rather, something strange failed to emerge. Where they expected to find galaxies scattered through space, like cities across a continent, they found almost nothing. The Bhuta's Void stretches across roughly 330 million light-years. To put that in perspective that feels almost manageable, imagine you could shrink our galaxy down to the size of a grain of sand. The Bhuta's Void would still be larger than a football stadium. It's a sphere of near emptiness sitting about 700 million light-years away from us, in a direction where we should see thousands upon thousands of galaxies twinkling in the cosmic night. Instead, astronomers have found only about 60 galaxies in the entire region. 60. In a space that, based on the average density of the universe, should contain several thousand. It's as if someone took a cosmic eraser and gently, methodically, removed nearly everything from a vast sphere of space, leaving behind only the faintest traces of what should have been there. What makes this even more unsettling is that we don't really know why it exists. The leading theory is that the void formed through a process that sounds almost gentle, but operates on scales that boggle the mind. Early in the universe's history, When things were still settling into the patterns we see today, small voids might have merged and grown, like soap bubbles combining into larger bubbles. Gravity, that familiar force that keeps your feet on the ground, and the moon in orbit worked in reverse here, not pulling things together, but allowing them to drift apart into the expanding emptiness. But even this explanation feels incomplete, like trying to describe a symphony by humming a few scattered notes. The Buddha's void is so large, so empty, so perfectly spherical that it pushes against the boundaries of what our current understanding of cosmology can comfortably explain. Some scientists have wondered whether we're seeing the signature of some unknown cosmic phenomenon, or whether the void is simply showing us the limits of what we can observe and understand about the universe's large-scale structure. There's something deeply unsettling about contemplating a place like this. We're used to thinking of space as filled with things: stars, planets, gas clouds, the occasional asteroid. Even the space between these objects isn't truly empty, but filled with particles, magnetic fields, the faint whisper of cosmic radiation left over from the birth of the universe itself. But the Boötes void is different. It's a place where even these faint traces of existence have been stretched thin, where the universe has become so dilute that matter itself seems almost theoretical. If you could somehow travel there, if you could park your impossible spacecraft right in the heart of the great nothing, what would you see? The honest answer is almost certainly nothing at all. No nearby stars to illuminate your journey. No distant galaxies to provide a sense of direction or scale. Just darkness stretching in every direction, so complete and so vast that light itself becomes a rare and precious thing. The nearest galaxy might be so far away that its light would appear as nothing more than the faintest possible glimmer, a single photon arriving every few minutes after a journey of hundreds of millions of years. You would be floating in a cosmic desert where even the horizon has been erased, where up and down, near and far, lose their meaning in the face of such overwhelming emptiness. And perhaps most unsettling of all, you would have time to think about it. The Boötes void isn't just empty, it's stable. It's not going anywhere. It's not filling up with new matter or collapsing under its own gravity. It's simply going to continue being empty for billions upon billions of years, long after our sun has burned out, long after our galaxy has merged with Andromeda, long after the last stars in the universe have flickered and died. It's a place that reminds us that the universe is not just vast beyond our comprehension, but that much of that vastness is filled with precisely nothing at all. No stories, no drama, no cosmic events to mark the passage of time, just silence and darkness and the slow, steady expansion of space itself, making the emptiness even more empty as the eons pass. The Boötes void challenges our deepest assumptions about existence itself. We live on a planet where every cubic inch is filled with something: air, water, rock, life in countless forms. We look up at the night sky and see it sprinkled with stars, and we imagine that this is what the universe is like everywhere: dense, busy, full of activity and matter and energy. But the great nothing whispers a different truth. It suggests that emptiness, not fullness, might be the universe's default state, that the galaxies and stars and planets we see scattered through space might be the exceptions, not the rule. That for every region of space filled with the drama of stellar birth and death, there might be vast spheres of cosmic loneliness, where nothing ever happens, where nothing ever has happened, where nothing ever will happen. There's a kind of terrible beauty in that thought. The Boötes void exists as a monument to possibility unrealized, to matter that never gathered, to stars that never formed, to stories that were never written in the language of light and gravity. It's a place that exists primarily as absence, as the cosmic equivalent of a held breath that never gets released, and yet, in its own way, the void serves a purpose in the grand architecture of the universe. These empty regions help define the structure of everything else, creating the scaffolding on which galaxies and galaxy clusters hang like ornaments on an invisible Christmas tree. The void doesn't just represent nothing, it helps create the something that surrounds it. But knowing this doesn't make it any less unsettling to contemplate. The Boötes void remains one of the most profoundly lonely places we've ever discovered, a region where the universe has forgotten how to be itself, where the normal rules of matter and energy and cosmic evolution seem to have simply stopped. As we drift deeper into our exploration of the universe's most haunting places, we'll discover that the great nothing is not alone in its strangeness. There are other voids, other regions where the cosmos has carved out spaces of profound emptiness. And perhaps even more unsettling, there are places where the universe hasn't forgotten how to exist, but has instead remembered how to exist in ways that challenge everything we thought we knew about the nature of reality itself. But for now, let's simply sit with the quiet terror of the Boötes void, this spherical monument to cosmic solitude, this place where the universe has achieved a kind of perfect, terrible peace. It's out there right now, 700 million light-years away, being empty with a patience and thoroughness that puts human loneliness to shame. And in that emptiness, perhaps, lies one of the most profound truths about our universe, that it is capable of creating spaces so vast and so empty that they make our own existence seem not just improbable, but miraculous. Every atom in your body, every breath you take, every thought you think represents a triumph over the cosmic tendency toward emptiness, a small but precious victory against the universe's apparent preference for nothing at all. Tonight, as we drift further into the cosmic unknown, let me tell you about another place that makes the great nothing seem almost welcoming by comparison. Imagine, if you will, a region of space so vast and so mysteriously empty that it has left scientists questioning the very foundations of how our universe came to be. This is the Eridanus Supervoid, and its discovery reads like a ghost story written in the language of physics. The tale begins not with telescopes pointed at distant galaxies, but with something far more subtle and strange. In the early 2000s, scientists were studying the cosmic microwave background, that faint afterglow of the Big Bang that still whispers through space after nearly 14 billion years. Think of it as the universe's baby picture, a snapshot of what things looked like when the cosmos first became transparent to light. This background radiation should be remarkably uniform, like a gentle, even glow filling all of space. But as researchers mapped it with ever-increasing precision, they noticed something deeply unsettling. There, in the direction of the constellation Eridanus, was a cold spot. Not just a little cool patch, but a region significantly colder than it had any right to be, according to our understanding of cosmic evolution. Cold spots in the cosmic microwave background aren't supposed to exist on this scale. The early universe was remarkably smooth, with only tiny fluctuations that would eventually grow into the galaxies and galaxy clusters we see today. Large cold regions simply shouldn't be there, like finding a patch of winter in the middle of a perfectly temperate spring day. But as astronomers investigated further, the mystery deepened. When they turned their telescopes toward this cold region, they discovered something that sent chills through the scientific community. The cold spot wasn't just an anomaly in the ancient light of the universe's birth. It corresponded to a supervoid, a region of space so empty it makes the Boötes void seem crowded by comparison. The Eridanus Supervoid stretches across roughly 1 billion light-years of space, located about 1.3 billion light-years from Earth. To put this in perspective that still feels manageable to our minds, if you could travel at the speed of light itself, it would take you 1 billion years just to cross from one side to the other. 1 billion years. That's roughly the amount of time it took for complex life to evolve from simple cells here on Earth. But size isn't the only thing that makes the Eridanus Supervoid so deeply unsettling. It's the connection to that cold spot in the cosmic microwave background that really keeps cosmologists awake at night. You see, when light from the early universe travels through a supervoid, it should lose energy climbing out of the void's gravitational well. This is called the integrated Sachs-Wolf effect, and it should make regions behind supervoids appear slightly cooler in the cosmic microwave background. The problem is that the cold spot is far colder than this effect should produce. It's as if the universe is showing us something that shouldn't exist according to our current understanding of physics. Some scientists have proposed that the Eridanus Supervoid might explain the cold spot, but even they admit the numbers don't quite add up. The void is impressive, but not quite impressive enough to account for the dramatic temperature difference we observe. This has led to some rather extraordinary suggestions. A few researchers have speculated that the cold spot might be evidence of our universe bumping up against another universe, a cosmic collision that left a bruise in the fabric of space-time itself. Others have wondered whether we're seeing the signature of physics beyond our current understanding, some exotic form of matter or energy that we haven't yet learned to recognize. The honest truth is that we simply don't know. The Eridanus Supervoid sits there in space, a billion light-years of near emptiness, connected to a cold spot that challenges our deepest theories about how the universe works. It's a cosmic puzzle written in the language of absence, a riddle posed by nothingness itself. What makes this place so haunting isn't just its size or its mystery, but what it represents about the limits of human knowledge. Here we are, clever primates who have learned to decode the whispers of creation itself, who can measure the temperature of space to fractions of a degree and map the large-scale structure of the cosmos with breathtaking precision. And yet, when we turn our instruments toward the Eridanus Supervoid, the universe simply shrugs and says, "I contain multitudes you do not understand." If you could somehow journey to this region of space, what would you find? Almost certainly nothing at all, but nothing on a scale that defies imagination. The few galaxies that do exist in this vast emptiness would be scattered like islands in an ocean so large that each island would be invisible to all the others. You could spend eternity travelling from one lonely galaxy to another, each one an isolated fortress of light, in an ocean of darkness so vast it makes infinity seem cozy. And all around you, as you drifted through this cosmic desert, would be the knowledge that you were floating through space that might hold clues to the deepest mysteries of existence itself. Every cubic meter of apparent emptiness might be whispering secrets about the nature of reality, about whether our universe is truly alone, or whether it rubs shoulders with other universes in dimensions we can't perceive. The Eridanus Supervoid forces us to confront the possibility that the universe is not just stranger than we imagine, but stranger than we can imagine. It's a place where the normal rules seem to break down, where the very fabric of space-time might bear the scars of cosmic events so profound they leave permanent marks in the structure of reality itself. But perhaps most unsettling of all is the reminder that our universe is still very much a work in progress, still revealing secrets that challenge everything we thought we knew. The Eridanus Supervoid has been there for billions of years, quietly being empty, quietly defying explanation, quietly suggesting that the cosmos holds mysteries we may never fully unravel. As we continue our gentle journey through the universe's most haunting places, we'll discover that emptiness is just one way the cosmos can unsettle us. But there are forces at work in the universe that make even the most profound voids seem peaceful by comparison. There are places where the universe hasn't forgotten how to exist, but has instead learned to exist in ways that bend the very foundations of physics. Yet for now, let's simply rest in the quiet terror of the Eridanus Supervoid, this billion light-year question mark carved into the heart of space itself. It reminds us that for all our scientific achievements, for all our telescopes and equations and careful measurements, the universe still holds secrets that make us feel very small and very young in the face of cosmic mysteries that dwarf our understanding. And perhaps that's not entirely a bad thing. There's something almost comforting about knowing that the universe still has the power to surprise us, to humble us, to remind us that we are still explorers in a cosmos far stranger and more wonderful than we ever dared to dream. Somewhere out there, 1.3 billion light-years away, the Eridanus Supervoid continues its patient existence, being empty with a thoroughness that makes even the vacuum of space seem crowded. It waits, silent and vast, holding its secrets close, whispering to us across the cosmic distances that reality is far more mysterious than we have yet learned to imagine. But if you think vast emptinesses are the most unsettling thing the universe has to offer, let me tell you about something that operates on the opposite end of the cosmic spectrum. A place where instead of nothing pulling at nothing, something immense and invisible is pulling at everything, including us, with a force so powerful it has reshaped the architecture of our local universe. This is the story of the Great Attractor, and it begins with one of the most disturbing discoveries in astronomy: the realization that we are not in control of our cosmic destiny. The story unfolds in the 1970s and 1980s, when astronomers were conducting what seemed like routine observations of galaxy motions. They were measuring redshift, that gentle stretching of light that tells us how fast objects are moving away from us in our expanding universe. It should have been straightforward work, the kind of careful cataloguing that forms the backbone of astronomical knowledge. But as the data accumulated, something deeply unsettling began to emerge. Our galaxy, the Milky Way, wasn't moving through space the way it should have been. Neither were our neighbours. The entire local group of galaxies, including the magnificent Andromeda Galaxy, appeared to be drifting in a specific direction at an alarming speed of roughly 600 kilometers per second. 600 kilometers per second. That's fast enough to circle the Earth in about an hour and a half. And it's not just us. Hundreds of thousands of other galaxies across vast stretches of the cosmos are all being pulled in the same direction, like leaves caught in an invisible cosmic current that defies explanation. The truly unsettling part? We couldn't see what was doing the pulling. The source of this gravitational tug lies hidden behind what astronomers call the zone of avoidance, a region of sky obscured by the dense stars and dust of our own galaxy. It's as if the universe has drawn a curtain across this particular corner of space, hiding whatever massive structure lurks there from our curious eyes. We can feel its influence, we can measure its effects, but we cannot see the puppet master pulling the strings. This invisible force has been given the rather ominous name of the Great Attractor, and it sits roughly 150 to 250 million light-years away from us in the direction of the constellation Norma. The uncertainty and distance only adds to its mysterious nature. Even our best instruments struggle to peer through the cosmic fog that conceals it, leaving us to infer its presence from the way it shepherds entire galaxies across the universe. What we do know is profoundly disturbing. The Great Attractor appears to be a gravitational anomaly of staggering proportions, a concentration of mass so immense that it can influence the motion of objects across hundreds of millions of light-years of space. It's not just pulling on individual galaxies, but on entire galaxy clusters, reshaping the large-scale structure of our cosmic neighbourhood with patient, inexorable force. Through painstaking observations that pierce partially through the galactic veil, astronomers have identified what appears to be a massive cluster of galaxies called the Norma cluster as a major component of the Great Attractor. But even this discovery raises more questions than it answers. The visible mass in this region, impressive as it is, doesn't seem sufficient to account for the gravitational influence we observe. There must be something else there, something hidden, something we don't yet understand. The implications are deeply unsettling when you really sit with them. We like to think of ourselves as autonomous travelers through space, riding our planet as it orbits our star, as our star orbits the center of our galaxy, as our galaxy makes its own stately procession through the cosmos. But the Great Attractor reminds us that we are not free agents in this universe. We are being pulled inexorably and invisibly towards something we cannot see. Every moment of your life, as you go about your daily routine, as you sleep and wake and dream and worry about perfectly reasonable earthly concerns, you are hurtling through space at 600 kilometers per second in the direction of this cosmic mystery. Your breakfast, your pet, your favorite book, the air you breathe, all of it is being drawn toward this invisible, gravitational leviathan that lurks behind the stars of our own galaxy. But the story becomes even more unsettling when we zoom out further. Recent research suggests that the Great Attractor itself might not be the final destination of our cosmic journey. There are hints, tantalizing and terrifying, that it too is being pulled by something even more massive and distant. Something called the Shapley supercluster, located even deeper in space, appears to be exerting its own gravitational influence on our entire region of the universe. This creates a kind of cosmic Russian nesting doll of gravitational influence. We are being pulled by the Great Attractor, which is itself being pulled by an even greater attractor, which might itself be influenced by structures so vast and distant we can barely detect them. Its gravitational influences all the way down, or rather, all the way up to scales that challenge our ability to comprehend the true architecture of the universe. The Great Attractor forces us to confront an uncomfortable truth about our place in the cosmos. We are not just small in terms of size, we are small in terms of agency. The path our galaxy takes through space, the direction of our cosmic journey, the ultimate fate of our local group of galaxies, all of these things are being determined by forces completely beyond our control, or even our ability to observe directly. There's something profoundly humbling about this realization. Here we are, having mapped the human genome, having sent probes to the edge of the solar system, having detected gravitational waves and photographed black holes, and yet we remain cosmic passengers on a journey whose destination we cannot see and whose driver we cannot identify. If you could somehow step outside the universe and look down at our cosmic neighborhood, you would see vast streams of galaxies all flowing in the same direction, like cosmic rivers converging towards some unseen ocean. You would see the Milky Way as just one small droplet in this immense current, carried along by forces that dwarf anything we experience in our terrestrial lives. The Great Attractor embodies a particular kind of cosmic horror, the horror of invisible influence. It's not the dramatic violence of exploding stars or the eerie emptiness of cosmic voids. It's the quiet, persistent reminder that we are not in control, that our galaxy and everything in it is subject to gravitational forces that operate on scales so vast they make our solar system seem like a mote of dust. And perhaps most unsettling of all is the knowledge that this influence has been shaping our cosmic destiny for billions of years. Long before life emerged on Earth, long before our solar system even formed, the matter that would eventually become our planet was already being shepherded through space by the invisible hand of the Great Attractor. In a very real sense, we owe our existence to this cosmic puppet master, this hidden force that helped guide the raw materials of our world to this particular corner of the universe. Every atom in your body has been on a journey spanning billions of years, a journey whose path was influenced by gravitational forces you cannot see pulling you toward destinations. You cannot know the calcium in your bones, the iron in your blood, the oxygen you breathe. All of it has been part of this vast cosmic migration since long before the Earth existed. The Great Attractor reminds us that the universe operates according to a logic that transcends human understanding and human control. We can measure its effects, we can map its influence, We can even make educated guesses about its nature. But we cannot escape its pull, we cannot change our cosmic trajectory, and we cannot fully comprehend the vast gravitational web in which we are forever entangled. As we drift deeper into our exploration of the universe's most haunting places, we'll discover that invisible influences are just one way the cosmos can unsettle our sense of cosmic security. There are places where the very structure of space and time breaks down, where the familiar laws of physics surrender to forces so extreme they challenge the foundations of reality itself. But for now, let us simply acknowledge our passenger status in this cosmic journey, our role as unwilling participants in a gravitational drama that began billions of years before we existed and will continue long after our sun has burned out. Somewhere out there, hidden behind the veil of our own galaxy, the great Attractor continues its patient work, pulling us and countless other galaxies toward whatever cosmic destiny awaits in the depths of space. We are all riders on this invisible current, all participants in a journey we did not choose toward a destination we cannot see. And in that realization lies both terror and wonder, the acknowledgement that we are part of something so much larger than ourselves that it makes our earthly concerns seem beautifully, preciously small. The great Attractor watches us from behind its curtain of stars, invisible but undeniable, reshaping the universe with quiet, inexorable force. And we, tiny passengers on our rocky world, continue our long journey through the cosmos, pulled by invisible hands toward whatever wonders and terrors await us in the depths of space and time. As we've journeyed through these vast emptinesses and invisible forces, you might think we've seen the universe at its most unsettling. But now I want to take you somewhere that exists at the very edge of physics itself, where the familiar laws that govern our daily lives simply give up and surrender to something far more terrifying than emptiness or invisible pull. I want to tell you about the event horizon of a black hole, a place that represents the ultimate point of no return. The story of this cosmic boundary begins, like so many of our most profound discoveries, with mathematics. In the early 20th century, following Einstein's revolutionary theory of general relativity, a German physicist named Karl Schwarzschild was working to understand what Einstein's equations really meant. Schwarzschild was actually serving as a soldier during World War I when he made his calculations, working out the mathematics of gravity and space-time in the trenches before tragically dying of an autoimmune disease just months after his discovery. What Schwarzschild found was both elegant and deeply disturbing. He calculated that around any massive object, there exists a radius where the curvature of space-time becomes so extreme that nothing, not even light itself, can escape. This invisible boundary became known as the event horizon, and it represents perhaps the most terrifying frontier in the known universe. The event horizon isn't a physical surface that you could touch or see. It's more like a mathematical ghost, a boundary in space-time itself that marks the point of no return. Cross this invisible line, and you are lost to the observable universe forever. Every particle of your being, every photon of light, every whisper of information that makes up your existence becomes trapped in an inexorable spiral toward the black hole's center. What makes this so deeply unsettling is the way it plays with our most basic understanding of time and space. From the outside, watching someone fall toward a black hole, time appears to slow to a crawl at the event horizon. You would see them freeze there, their image growing redder and dimmer as their light is stretched by the extreme gravity, until they fade from view entirely. But from their perspective, time flows normally as they plunge past the horizon and toward the unknowable center. Event horizons exist around every black hole in the universe, from the stellar mass black holes scattered throughout our galaxy to the supermassive monsters that lurk at the centers of galaxies. They range in size from a few kilometers across to larger than our solar system, but they all share the same terrible property. They are boundaries beyond which the normal rules of existence cease to apply. For most of history, these event horizons remained purely theoretical, mathematical curiosities that existed only in the equations of physicists. But in 2019, something extraordinary happened. The Event Horizon Telescope, a planet-sized array of radio telescopes working in perfect coordination, managed to capture the first image of an event horizon. The photograph showed the shadow of the supermassive black hole at the center of the galaxy M87, located 53 million light-years away. The image was both beautiful and terrifying. There, against the glowing accretion disk of superheated matter spiraling into the black hole, was a perfect circle of absolute darkness. The event horizon made visible a hole in space so dark it seemed to swallow light itself. It was like looking at the edge of existence, the boundary where our universe simply stops making sense. But if event horizons represent the edge of the knowable universe, what lies at the very heart of a black hole is something even more profoundly unsettling. This brings us to perhaps the most terrifying concept in all of physics, the singularity. The singularity is where our understanding of reality breaks down completely. It's a point of infinite density where matter is crushed beyond all comprehension, where the very concepts of space and time lose their meaning. The mathematics that describe it involve infinities, those troublesome numbers that make physicists deeply uncomfortable because they suggest we're missing something fundamental about how the universe works. At the center of every black hole, hidden beneath the event horizon, like a cosmic secret too terrible to reveal, lies this point where the laws of physics, as we know them, simply surrender. General relativity, the theory that describes gravity and space-time with beautiful precision everywhere else in the universe, breaks down at the singularity. Quantum mechanics, our best description of the microscopic world, has nothing useful to say about what happens there. It's a place where cause and effect, space and time, matter and energy, all the familiar categories we use to make sense of existence, become meaningless. What makes the singularity so terrifying isn't just our lack of understanding, but what that lack of understanding represents. Here is a place that exists in our universe, that we can prove must be there through mathematics and observation, and yet it lies forever beyond our ability to comprehend or observe. It's as if the universe has placed a sign reading "No trespassing" at the very heart of its most extreme objects. If you could somehow survive the journey to a singularity, if you could pass through the event horizon and endure the crushing tidal forces that would stretch and compress your body in ways that defy imagination, you would encounter something that isn't just strange or dangerous, but fundamentally unknowable. The singularity represents the ultimate frontier, the place where human understanding hits an absolute wall. And these places exist throughout our universe. Every stellar mass black hole contains one. Every supermassive black hole harbours one at its core. They are scattered through space like cosmic question marks, like points where the universe has forgotten how to be itself. Some are the remnants of massive stars that collapsed at the end of their lives. Others grew over billions of years, feeding on matter and merging with other black holes, growing ever larger and more massive. The thought that these singularities exist right now, scattered throughout our galaxy and beyond, is profoundly unsettling. They represent the universe's capacity for creating conditions so extreme they transcend our ability to understand them. They are places where the comfortable predictability of physics gives way to something far more mysterious and terrible. What's perhaps most disturbing is that singularities might not be rare cosmic curiosities, but fundamental features of how the universe works. Some physicists speculate that our entire universe might have emerged from a singularity during the Big Bang, that everything we see around us, Every star and planet and galaxy, every atom in your body, might have its ultimate origin in one of these points of infinite density and unknowability. This suggests that the universe doesn't just contain mysteries, it is built from mystery. The very foundation of existence might rest on something that lies forever beyond our ability to comprehend, like a cosmic joke played on curious creatures who have the audacity to ask how things really work. Yet even as we confront these ultimate limits of knowledge, there's something oddly comforting about knowing they exist. The singularities remind us that for all our scientific achievements, for all our telescopes and equations and careful observations, the universe still holds secrets that make us feel appropriately humble in the face of cosmic mystery. But if you think the theoretical terrors of singularities are unsettling, let me tell you about a place much closer to home that poses a more immediate and tangible threat. Right here in our own galaxy, sitting at the very centre of the Milky Way, like a cosmic spider in its web, lurks one of the most powerful and terrifying objects we've ever discovered. This is Sagittarius A, and it's been quietly devouring matter and warping space-time just 26,000 light-years away from us for billions of years. The story of its discovery reads like a detective novel, with clues scattered across decades of careful observation and growing suspicion that something massive and dark was lurking at the heart of our galaxy. The first hints came in 1994, when astronomers Bruce Ballack and Robert Brown detected a strong radio source coming from the direction of the constellation Sagittarius. They were studying the galactic center, trying to peer through the dense clouds of gas and dust that obscure our view of the galaxy's core. What they found was something emitting powerful radio waves, something that seemed far too energetic to be an ordinary star. As technology improved and observations became more precise, the picture that emerged was increasingly disturbing. Something at the center of our galaxy was exerting gravitational influence on a scale that dwarfed anything else in our cosmic neighborhood. Stars were observed orbiting this invisible object at tremendous speeds, their paths revealing the presence of something with a mass equivalent to 4 million of our suns, all compressed into a region no larger than our solar system. 4 million suns worth of matter, crushed into a space that, while enormous by human standards, is essentially a point when considered on galactic scales. The gravitational field created by such an object is so intense that it warps space-time itself, creating the event horizon we discussed earlier, a boundary beyond which nothing can escape. For years, Sagittarius A remained an invisible monster, its presence inferred only through its gravitational effects on nearby stars and gas clouds. We could see the evidence of its feeding, the way it occasionally flared with energy as matter spiraled into its grasp, but the black hole itself remained hidden behind its own event horizon, a dark secret at the heart of our cosmic home. Then in 2022, something remarkable happened. Using the same planet-spanning array of telescopes that had captured the first image of the black hole in M87, scientists managed to photograph the shadow of Sagittarius A itself. There it was, our own galactic monster, revealed for the first time as a dark circle surrounded by the glowing matter of its accretion disk. The image was both triumphant and deeply unsettling. Here was proof that we share our galaxy with a supermassive black hole, a gravitational leviathan that could, in principle, devour our entire solar system without even noticing. It sits there at the galactic center like a cosmic Charybdis, quietly pulling in matter and energy, growing ever so slightly larger with each meal. What makes Sagittarius A particularly unnerving isn't just its size or its power, but its proximity and its patience. It's close enough to us that we can study it in detail, close enough that we can watch stars orbit around it like moths around a flame. Some of these stars approach so closely that they experience time dilation effects. their clocks running measurably slower than ours due to the intense gravitational field. Yet despite its proximity, Sagittarius A poses no immediate threat to Earth. We orbit far out in the galactic suburbs, safe from its immediate gravitational influence. But that safety comes with an expiration date. Over the billions of years to come, as our galaxy evolves and changes, as it eventually merges with the Andromeda Galaxy in about 4.5 billion years, the dynamics of our cosmic neighborhood will shift in ways we can barely predict. The thought that we live in a galaxy with such a monster at its heart is profoundly unsettling. Every night, when you look up at the Milky Way stretching across the sky, you're looking toward the direction of this supermassive black hole. Every star you see, every planet orbiting those stars, every possible civilization that might exist in our galaxy, all of it exists in the shadow of Sagittarius A. The black hole serves as a constant reminder of the universe's capacity for creating objects of such extreme properties that they challenge our understanding of physics itself. It's a place where matter disappears forever, where time stretches and warps, where the familiar rules of existence give way to something far more strange and terrible. And Sagittarius A is not unique. Every major galaxy appears to harbour a supermassive black hole at its centre, these cosmic engines that help shape the evolution of galaxies themselves. They are not just destroyers but creators, their gravitational influence helping to organise matter on galactic scales, their feeding frenzies triggering star formation in ways we're only beginning to understand. This brings us to perhaps the most unsettling realisation of all. These monsters might be necessary. The supermassive black holes at galactic centres might play crucial roles in the evolution of galaxies, in the formation of stars, in the very processes that make life possible. We might owe our existence in part to the presence of these gravitational leviathans. The universe, it seems, builds its most beautiful structures around its most terrifying objects. Galaxies spiral majestically around supermassive black holes, stars form in the gravitational wake of these cosmic monsters. Life emerges on planets, orbiting stars that exist because of the complex gravitational dance between matter and these points of infinite density. As we continue our journey through the universe's most haunting places, we'll discover that Sagittarius A is just one example of how the cosmos creates beauty and terror in equal measure. There are objects out there that make our galactic black hole seem almost quaint by comparison, places where the universe has learned to concentrate energy and matter in ways that challenge our deepest understanding of what's possible. But for now, let us simply acknowledge our cosmic neighbour, this 4 million solar mass reminder of the universe's capacity for creating objects that exist at the very edge of comprehension. Sagittarius A sits there at the heart of our galaxy, patient and eternal, a gravitational god around which our entire cosmic home slowly rotates. Every atom in your body has spent billions of years orbiting this monster at a safe distance, part of the grand galactic dance that has shaped our cosmic neighbourhood since long before the Earth existed. And every night, as you drift off to sleep, Sagittarius A continues its patient work, warping space-time and swallowing matter, a dark heart beating at the centre of our cosmic home. It reminds us that even in our own galaxy, even in the cosmic space we call home, there lurk forces and objects that dwarf human understanding. We are not just small in size, but small in comprehension, tiny conscious beings trying to make sense of a universe that contains objects like Sagittarius A, places where the familiar rules of reality break down and surrender to something far more mysterious and profound. The black hole waits there in the galactic centre, invisible but undeniable, a reminder that the universe is stranger and more terrible than we have yet learned to imagine, and we, riding our small planet around our ordinary star, continue our cosmic journey through a galaxy shaped by forces that make our earthly concerns seem beautifully, preciously small. Now, as we drift further into the cosmic depths, let me tell you about objects so violently energetic they make our supermassive black holes seem almost peaceful by comparison. These are the quasars, and they represent some of the most powerful and terrifying phenomena the universe has ever produced. They are cosmic lighthouses gone mad, beacons of destruction that outshine entire galaxies with their fury. The story of quasars begins in the early 1960s, when astronomers were conducting radio surveys of the sky, mapping the sources of radio waves that reached Earth from deep space. Most of these sources appeared as fuzzy blobs through telescopes, clearly distant galaxies or nebulae, but some appeared as simple points of light, indistinguishable from ordinary stars. The puzzle was that these star-like objects were emitting far more radio energy than any normal star should produce. In 1963, an astronomer named Martin Schmidt was studying one of these mysterious objects, catalogued as 3C273. When he analysed its light spectrum, expecting to see the familiar fingerprint of a nearby star, what he found instead changed our understanding of the universe forever. The spectrum was completely wrong for a star. It showed hydrogen lines, but they were shifted so dramatically toward the red end of the spectrum that Schmidt initially thought he was looking at an entirely unknown type of object. Then the realization hit him like a cosmic thunderbolt. The lines weren't unknown at all. They were ordinary hydrogen lines, but shifted by the expansion of the universe itself. This seemingly star-like point of light wasn't nearby at all. It was billions of light years away, so distant that its light had been travelling through space for most of the age of the universe. And if it was that far away but still visible from Earth, it had to be producing energy on a scale that defied comprehension. Schmidt had discovered the first quasar, short for quasi-stellar radio source, and with it he had opened a window into one of the universe's most violent processes. Quasars are not stars at all, but the brilliant cores of distant galaxies powered by supermassive black holes in the act of feeding. But these are not the quiet, patient feeding processes we might imagine. These are cosmic feeding frenzies of unimaginable violence and energy. At the heart of a quasar lies a supermassive black hole, often billions of times more massive than our Sun, surrounded by a swirling disk of matter called an accretion disk. As matter spirals inward toward the event horizon, it heats up to millions of degrees, glowing with such intensity that it outshines all the billions of stars in the host galaxy combined. The energy output is so enormous that quasars can be seen from across the observable universe, their light travelling for billions of years to reach our telescopes. But the energy output is just the beginning of what makes quasars so terrifying. As matter falls into the supermassive black hole, not all of it crosses the event horizon. Some of it gets accelerated and ejected along the black hole's magnetic field lines, creating jets of plasma that shoot out from the poles at speeds approaching the speed of light itself. These jets can extend for millions of light years, stretching across intergalactic space like cosmic blowtorches. To put the scale of quasar energy in perspective, consider this. A typical quasar can emit more energy in a single second than our Sun will produce in its entire 10 billion year lifetime. Some of the most powerful quasars shine with the brightness of 1,000 trillion suns. If you replace the Sun in our solar system with an average quasar, the Earth would be instantly vaporized, along with everything else within several light years. The jets produced by quasars are equally terrifying. These streams of particles and energy can stretch across distances so vast that light takes millions of years to travel from one end to the other. They tear through the cosmos like cosmic searchlights, heating up gas clouds, triggering star formation in some regions while sterilizing others completely. If one of these jets were pointed directly at Earth, the radiation would strip away our atmosphere and obliterate any possibility of life. What makes quasars particularly unsettling is that they represent the universe at its most violent and chaotic. These are not the gentle, predictable processes we see in our local cosmic neighbourhood. These are cosmic catastrophes, black holes gone berserk, feeding with such intensity that they become visible across the entire observable universe. They remind us that the cosmos is capable of violence on scales that make our most powerful nuclear weapons seem like fireflies. Fortunately for us, most quasars exist in the distant universe, meaning we see them as they were billions of years ago, when the cosmos was younger and more chaotic. The light we observe from these objects has been travelling through space since long before our solar system existed, carrying news of cosmic violence from an era when the universe was still settling into its current, more peaceful state. But even their distance doesn't make them entirely safe. The radiation from quasars can affect the evolution of galaxies across vast stretches of space. Their jets can trigger or suppress star formation in neighbouring regions. They represent forces so powerful they can reshape the large-scale structure of the universe itself. Cosmic bulldozers that clear paths through intergalactic space. The knowledge that such objects exist, that the universe is capable of creating engines of destruction so powerful they can be seen from billions of light years away, is profoundly humbling. It reminds us that for all the violence we see on Earth, for all the natural disasters and cosmic threats we worry about, there are forces at work in the universe that operate on scales so vast they make our concerns seem infinitesimal. As we continue our gentle journey through the cosmos's most haunting places, let me tell you about objects that exist at the intersection of physics and nightmare, places where the familiar forces of nature have been amplified to levels that challenge our understanding of what matter itself can endure. These are the Magnetars, and they represent perhaps the most violently magnetic objects in the known universe. The story of Magnetars begins with one of the most dramatic events the cosmos can produce, the death of a massive star. When a star, at least 10 times more massive than our Sun, reaches the end of its life, it doesn't fade gently into the cosmic night. Instead, it explodes in a supernova, a blast so powerful it can briefly outshine an entire galaxy. But sometimes, in the aftermath of this cosmic violence, something even more extreme is born. Most neutron stars, the collapsed cores left behind by supernovas, are already objects that push the boundaries of physical possibility. Imagine compressing the entire mass of our Sun into a sphere only about 20 kilometers across. The density is so extreme that a teaspoon of neutron star material would weigh as much as Mount Everest. But magnetars take this extremity and amplify it in ways that seem almost impossible. A magnetar possesses a magnetic field so powerful it defies easy comprehension. While Earth's magnetic field is strong enough to deflect solar wind and create the aurora, a magnetar's field is a quadrillion times stronger. To put this in perspective, if a magnetar were located halfway between Earth and the Moon, it could erase every credit card on our planet instantly. At closer range, it would literally tear apart the atoms in your body, ripping electrons from their orbits and stretching matter into impossible configurations. The magnetic field of a magnetar is so intense that it warps the very structure of space around it. Near the surface, the field becomes strong enough to affect the quantum vacuum itself, creating conditions that exist nowhere else in the universe. It's as if these objects have learned to weaponize one of the fundamental forces of nature, turning magnetism into something that belongs more in a cosmic horror story than in a physics textbook. What makes magnetars particularly terrifying is their unpredictability. These objects exist in a constant state of magnetic tension, their crusts cracking and shifting under the stress of field lines that twist and snap like cosmic rubber bands. When these magnetic field lines reconnect, they release energy equivalent to millions of hydrogen bombs in a fraction of a second. These events, called starquakes, send bursts of gamma rays and X-rays screaming across the cosmos at the speed of light. The most powerful magnetar flare ever recorded occurred in December 2004 when an object designated SGR 1806-20 released more energy in 1/10 of a second than our Sun produces in 100,000 years. This burst of radiation, originating from a source 50,000 light-years away, was powerful enough to measurably affect Earth's atmosphere, ionizing particles in our upper atmosphere and temporarily disrupting radio communications across the planet. If this same event had occurred from a magnetar just 10 light-years away, the radiation burst would have been powerful enough to strip away our ozone layer and trigger a mass extinction. The gamma rays would have penetrated deep into Earth's atmosphere, creating nitrogen oxides that would have depleted our protective ozone shield for years. Life on our planet's surface would have been exposed to lethal levels of ultraviolet radiation from the Sun. The thought that such objects exist scattered throughout our galaxy like cosmic landmines is deeply unsettling. Most known magnetars are located tens of thousands of light-years from Earth, safely distant but still close enough to remind us of their existence with their occasional outbursts. We detect their signals as brief, intense flashes of high-energy radiation that light up our instruments like cosmic flashbulbs. What's perhaps most disturbing about magnetars is how little we understand about them. We know they exist, we can measure their incredible magnetic fields, we can detect their violent outbursts, but the physics of how such extreme magnetic fields are generated and maintained pushes against the very limits of our understanding. These objects exist in a regime where quantum mechanics and general relativity intersect in ways we're only beginning to explore. The surfaces of magnetars are landscapes of impossible extremes. The magnetic field is so strong that it constrains matter into needle-like structures aligned with the field lines. The gravity is so intense that the escape velocity approaches a significant fraction of the speed of light, and the temperature can reach millions of degrees, hot enough to emit X-rays that make the object glow like a cosmic ember in the darkness of space. If you could somehow approach a magnetar, the experience would be unlike anything else in the universe. Long before you reach the surface, the magnetic field would begin to affect your body in ways that defy imagination. The field would interact with the iron in your blood, the electrical activity in your nervous system, the very atoms that make up your cells. You would be stretched and compressed by magnetic forces so powerful they would reshape matter at the subatomic level. But perhaps the most unsettling aspect of magnetars is their longevity. These objects can remain active for thousands of years, occasionally flaring with violence that can be detected across galactic distances. They are cosmic time bombs scattered throughout our galaxy, each one a reminder that the universe contains forces so extreme they challenge our deepest understanding of physics. As we drift deeper into our exploration of cosmic terror, magnetars serve as a reminder that the universe's capacity for violence extends far beyond the obvious threats of black holes and exploding stars. Sometimes the most frightening objects are those that take familiar forces and amplify them to levels that seem almost supernatural. Magnetars represent the universe at its most magnetically violent, objects where one of nature's fundamental forces has been concentrated and twisted into something that belongs at the very edge of physical possibility. The knowledge that such objects exist, that our galaxy contains dozens of these magnetic monsters, each one capable of affecting our planet from thousands of light-years away, adds another layer to the cosmic anxiety that comes with truly understanding our place in the universe. We live not just in a cosmos filled with black holes and voids, but in a galaxy where magnetic fields can reach strengths that make our most powerful Earth-based magnets seem like children's toys. Tonight, As you settle into the comfort of your earthly surroundings, remember that scattered throughout our cosmic neighborhood are objects so magnetically powerful they could affect our planet from distances that light takes decades to cross. They wait in the darkness, these magnetars, occasionally flaring with violence that reminds us just how extreme the universe can be when it really sets its mind to creating something that pushes against the very boundaries of physical law. But if you think individual objects of cosmic violence are unsettling, let me tell you about something that operates on an even grander scale, something that suggests our entire observable universe might be caught in a cosmic current we can barely detect and certainly cannot explain. This is the story of the dark flow, and it represents one of the most mysterious and potentially terrifying discoveries in modern cosmology. The tale begins in 2008, when a team of astronomers was analysing data from NASA's Wilkinson Microwave Anisotropy Probe, a satellite designed to study the cosmic microwave background with unprecedented precision. They were looking for tiny variations in this ancient light, the afterglow of the Big Bang itself, hoping to learn more about the early universe and the large-scale structure of the cosmos. What they found instead was something that shouldn't exist according to our understanding of how the universe works. Massive clusters of galaxies, some located billions of light-years away from us, all appeared to be moving in the same direction through space, not just drifting randomly as cosmic expansion would suggest, but flowing like a vast river toward a specific region of the sky at speeds exceeding 600 kilometers per second. This coordinated motion was dubbed the dark flow, and it represents one of the most profound mysteries in modern astronomy. Galaxy clusters, as far as 2.5 billion light-years away, structures containing thousands of individual galaxies and trillions of stars, all appear to be caught in the same cosmic current, all heading toward the same mysterious destination beyond the edge of our observable universe. What makes the dark flow so deeply unsettling is what it implies about the nature of reality itself. According to our best theories of cosmic evolution, the observable universe should be roughly homogeneous on large scales. The Big Bang should have created a cosmos where matter is distributed more or less evenly, where large-scale motions are random and chaotic, not organized into vast flows spanning billions of light-years. But the dark flow suggests something entirely different. It hints at the presence of massive structures or forces beyond the edge of our observable universe, influences so powerful they can affect the motion of galaxy clusters across a significant fraction of the visible cosmos. It's as if we're seeing the wake of some cosmic leviathan, the gravitational ripple created by something so massive and so distant we may never be able to observe it directly. The implications are staggering and terrifying. If the dark flow is real, it means our observable universe, vast as it is, may be just a small part of something much larger and stranger. It suggests that beyond the cosmic horizon, beyond the edge of what we can see, there might be structures or entities of such enormous scale that they can influence the motion of galaxies from distances we can barely imagine. Some theories propose that the dark flow might be caused by the gravitational influence of matter that existed before cosmic inflation, relics from an earlier epoch of the universe, that were stretched beyond our observational horizon, but still exert their influence across the cosmic void. Others suggest we might be seeing evidence of parallel universes, other cosmic bubbles whose gravitational influence somehow reaches across the space between realities. Even more unsettling is the possibility that the dark flow represents something we don't yet have the physics to understand. It might be evidence of extra dimensions, of modifications to gravity on cosmic scales, or of entirely new forces that operate beyond our current theoretical framework. It could be the signature of cosmic strings, theoretical objects left over from the universe's earliest moments, or the influence of domain walls that separate regions of space with different physical properties. The dark flow forces us to confront the possibility that our understanding of the universe is fundamentally incomplete. Here we are, having mapped the cosmic microwave background to exquisite precision, having detected gravitational waves and photographed black holes, having traced the evolution of the cosmos back to its first few moments. And yet we've discovered evidence of something that challenges our most basic assumptions about cosmic structure and evolution. What's particularly unnerving is the scale of the phenomenon. This isn't some local anomaly, some quirk of our cosmic neighborhood that we can explain away with known physics. The dark flow involves matter across billions of light years of space, structures so vast that light takes eons to travel from one end to the other, all moving in coordinated fashion towards something we cannot see. If you could somehow step outside our observable universe and look down at this cosmic flow, you would see vast streams of galaxies, all heading in the same direction, like leaves caught in a river, whose source and destination remain forever hidden from view. You would see our own galaxy as just one small participant in this cosmic migration, carried along by forces whose nature and origin we can only guess at. The dark flow reminds us that for all our scientific achievements, we remain cosmic children trying to understand a universe that may be far stranger and more complex than we have yet imagined. It suggests that the cosmos we can observe, vast as it seems, may be just the visible tip of something so much larger that it makes our observable universe seem like a puddle compared to an ocean. As we continue our journey through the universe's most haunting places, the dark flow serves as a reminder that some of the most terrifying discoveries are not individual objects or phenomena, but revelations about the nature of reality itself. Sometimes the most frightening thing we can discover is evidence that our understanding is incomplete, that the universe holds secrets so profound they challenge our deepest assumptions about existence itself. The dark flow continues even now, as you read these words, carrying vast structures of matter toward destinations unknown. Somewhere beyond the edge of our vision, something of unimaginable scale is pulling at the very fabric of our cosmic neighborhood, reshaping the universe in ways we can detect but cannot fully comprehend. It's a reminder that we live not just in a universe filled with violent objects and empty voids, but in a cosmos where the largest structures themselves may be subject to influences that operate on scales so vast they make our observable universe seem like a single grain of sand on an infinite beach. The dark flow whispers to us across the cosmic distances that reality is stranger, larger, and more mysterious than we have yet learned to imagine. Tonight, as we float deeper into the cosmic abyss, let me tell you about objects that wander the universe like cosmic ghosts, invisible and untethered, carrying with them the power to obliterate entire solar systems without warning. These are the rogue black holes, and they represent perhaps the most quietly terrifying threat our galaxy has to offer. The story of these wandering destroyers begins with violence. When massive stars die in supernova, they sometimes leave behind black holes that inherit not just the star's mass, but also its motion through space. Most of the time, these stellar remnants remain gravitationally bound to their birthplace, becoming part of binary systems or settling into predictable orbits within their galactic neighborhoods. But sometimes, through gravitational interactions or the asymmetric explosion of their parent star, these black holes are given a cosmic kick that sends them flying through space like bullets fired from an invisible gun. Other rogue black holes have even more dramatic origins. When galaxies collide and merge, their central supermassive black holes can be ejected through gravitational slingshot effects, hurled out into intergalactic space at speeds that can reach thousands of kilometers per second. These cosmic refugees carry with them masses equivalent to millions or billions of suns, wandering through the void with no fixed address and no predictable destination. What makes rogue black holes so profoundly unsettling is their invisibility. Unlike the black holes at galactic centers, which announce their presence with brilliant accretion disks and jets of high-energy radiation, rogue black holes drift through space in perfect darkness. They emit no light, produce no obvious signals, and leave no trail to mark their passage. They are the universe's ultimate stealth predators, invisible until the moment they begin to devour. The only way we can detect these wandering monsters is through their gravitational effects. Occasionally, one will pass between Earth and a distant star, causing the star's light to bend and brighten in a phenomenon called gravitational microlensing. For a brief moment, the rogue black hole acts like a cosmic magnifying glass, betraying its presence through the way it warps the light from more distant objects. In 2022, NASA scientists announced what may be the first confirmed detection of a rogue black hole using this technique. Located roughly 5,000 light-years away from Earth, this invisible wanderer revealed itself only through the way it bent starlight during its passage across our line of sight. The observation represents a breakthrough in our ability to detect these cosmic nomads, but it also serves as a chilling reminder of how many others might be out there, drifting unseen through the darkness. Current estimates suggest there could be millions of rogue black holes wandering through our galaxy alone. Think about that for a moment. Millions of invisible gravitational monsters, each one capable of tearing apart planets and swallowing stars, drifting through space with no fixed course and no way to predict their movements. Some might be stellar mass black holes, relatively small, but still capable of devastating any solar system they encounter. Others could be intermediate mass wanderers, or even rogue supermassive black holes ejected from their home galaxies during cosmic collisions. The terrifying randomness of their paths means that one could be heading toward our solar system right now, and we might not know until it was far too late. Unlike asteroids or comets, which we can track and predict, rogue black holes remain invisible until they begin to interact gravitationally with nearby objects. By the time we detected one approaching our solar system, it might already be close enough to disrupt planetary orbits or, in the worst-case scenario, to begin consuming our Sun. If a rogue black hole were to pass through our solar system, the effects would depend on its mass and trajectory, but none of the scenarios are pleasant to contemplate. A near miss might simply disrupt the orbits of the outer planets, sending them careening into new trajectories that could destabilize the entire system over millions of years. A closer encounter could eject planets from their orbits entirely, flinging Earth into the cold depths of interstellar space, or sending it spiraling into the Sun. But perhaps most terrifying of all would be a direct encounter with our star. If a rogue black hole were to begin feeding on the Sun, we would witness our life-giving star being slowly devoured from within. The process might take years or decades, but the outcome would be inevitable. Our Sun would be consumed, its light would fade, and our planet would freeze into a lifeless ball of ice, drifting through the cosmic darkness. The knowledge that such objects exist, that they wander through our galaxy in numbers we can only estimate, adds a particular flavour of cosmic anxiety to our understanding of our place in the universe. We worry about asteroid impacts and solar flares, about supervolcanoes and climate change, but rogue black holes represent a threat that operates on an entirely different scale. They are cosmic wildcards that could reshape or destroy our entire solar system, with no warning and no possibility of defense. What makes this threat even more unsettling is its randomness. Unlike most cosmic dangers, which operate on predictable timescales and follow observable patterns, rogue black holes are genuinely unpredictable. They don't follow regular orbits or announce their presence with obvious signals. they simply exist, scattered throughout the galaxy like invisible mines waiting to detonate, each one a reminder that the universe contains forces capable of ending our story without notice or ceremony. As we drift further into our exploration of cosmic terror, rogue black holes serve as a perfect example of how the universe combines immense power with complete unpredictability. They represent death from the dark, invisible harbingers of destruction that could be anywhere, heading in any direction, arriving at any time. In a cosmos already filled with visible threats and obvious dangers, they remind us that some of the most terrifying possibilities are the ones we cannot see coming. But if wandering black holes represent cosmic stealth and unpredictability, let me tell you about an object that takes these concepts and amplifies them to levels that challenge our understanding of what's physically possible. Deep in the cosmos, roughly 10.5 billion light-years away, lurks something so massive and so energetic that it defies conventional explanations for how such objects can exist. This is TON 618, and it represents perhaps the most extreme example of cosmic violence we've ever discovered. The story begins in the 1950s, when astronomers conducting a survey of blue stellar objects identified what appeared to be a faint star in the constellation Draco. For decades, TON 618 was catalogued as nothing more than an unusually blue point of light, one entry among thousands in astronomical databases. But as our instruments grew more sophisticated and our understanding of the cosmos deepened, the true nature of TON 618 began to emerge. What astronomers had initially mistaken for a nearby star was revealed to be something far more extraordinary and terrifying. TON 618 is not a star at all, but a hyperluminous quasar powered by what may be the most massive black hole ever discovered. The numbers associated with TON 618 are so extreme they seem almost fictional. Current estimates place the mass of its central black hole at approximately 66 billion times the mass of our Sun. To put this in perspective, the supermassive black hole at the centre of our own galaxy, Sagittarius A, weighs in at about 4 million solar masses. TON 618's central monster is more than 16,000 times more massive than the black hole that anchors our entire galactic home. If you could somehow replace Sagittarius A with the black hole from TON 618, the gravitational effects would be catastrophic beyond imagination. The increased gravity would disrupt the orbits of stars throughout the galaxy, triggering a cascade of stellar collisions and ejections that would tear apart the Milky Way's spiral structure. Stars would be flung out of the galaxy entirely or sent plummeting toward the central monster, feeding it and making it even more massive in a runaway process of cosmic destruction. But the mass of TON 618's black hole is only part of what makes this object so terrifying. The energy output is equally staggering. This hyperluminous quasar shines with the brightness of 140 trillion suns, making it one of the most luminous objects ever discovered. If TON 618 were located at the centre of our solar system, its radiation would instantly vaporize every planet, moon, and asteroid within several light years. Earth would be reduced to its component atoms in a fraction of a second. The fact that we can observe TON 618 at all, despite its enormous distance, speaks to the incredible violence of the processes occurring at its core. The light we see from this object has been travelling through space for most of the age of the universe. When the photons now reaching our telescopes first began their journey, the universe was less than 4 billion years old, a cosmic infant compared to its current age of nearly 14 billion years. This means we're seeing TON 618 as it existed in the early universe, when conditions were very different from those we observe today. The fact that such a massive black hole could exist so early in cosmic history challenges our understanding of how these objects form and grow. According to current theories, it should take much longer for black holes to reach such enormous masses, even under the most favourable conditions. The existence of TON 618 suggests that the early universe was capable of creating conditions so extreme that black holes could grow at rates far exceeding what our models predict. It hints at processes of cosmic evolution that we don't yet understand, mechanisms for concentrating matter and energy that operate beyond the boundaries of our current theoretical framework. What makes TON 618 particularly unsettling is not just its size or energy output, but what it represents about the universe's capacity for creating objects that push against the very limits of physical possibility. This is not just a large black hole or a bright quasar. This is something that exists at the extreme edge of what we thought was possible. A cosmic monster that forces us to reconsider our understanding of how matter and energy can be concentrated and organized. If you could somehow approach TON 618, the experience would be unlike anything else in the universe. Long before you reach the vicinity of the black hole itself, you would encounter the blazing accretion disk, a swirling maelstrom of superheated matter that outshines entire galaxies. The radiation environment would be so intense that any form of matter, any possible spacecraft or protective technology would be instantly destroyed by the flood of high-energy photons. The jets extending from TON 618's poles stretch across millions of light-years, cosmic blowtorches that tear through intergalactic space with energy densities that can trigger or suppress star formation across vast regions. These jets represent the black hole's way of sharing its violence with the universe at large, ensuring that its influence extends far beyond its immediate gravitational reach. Perhaps most disturbing of all is the knowledge that TON 618 is still out there, still feeding, still growing, even though we see it as it was billions of years ago. Somewhere in the depths of space, this cosmic monster continues its patient work of devouring matter and converting it into energy. It has been feeding for billions of years, and it will continue feeding for billions more, growing ever larger and more massive with each passing eon. The existence of objects like TON 618 reminds us that the universe operates on scales and with energies that make our earthly concerns seem infinitesimal. While we worry about the relatively gentle energy output of our own sun, about solar flares and radiation that might affect our technology, there are objects in the cosmos that produce energy at rates that dwarf our entire solar system's output by factors of trillions. As we continue our journey through the universe's most haunting places, TON 618 serves as a reminder that cosmic violence operates on scales we can barely comprehend. It represents the universe at its most energetically extreme, a place where matter and energy have been organized in ways that challenge our deepest understanding of physical law. Tonight, as you rest in the gentle light of our modest sun, remember that scattered throughout the cosmos are objects like TON 618, cosmic furnaces that burn with the brightness of hundreds of trillions of stars. They remind us that, for all the comfort and predictability of our earthly existence, we live in a universe capable of creating objects so extreme they exist at the very edge of what physics allows. But if individual objects of cosmic extremity are unsettling, let me tell you about something that represents perhaps the ultimate frontier of human knowledge and cosmic terror. This is not a place we can point to with our telescopes or visit with our imaginations. It is the edge of everything we can ever know, the boundary beyond which reality itself becomes unknowable. This is the edge of the observable universe, and it represents the most profound and terrifying boundary in all of existence. Unlike the event horizon of a black hole, which marks the point beyond which matter cannot escape, the edge of the observable universe marks the point beyond which information itself cannot reach us. It is not just a physical boundary, but an informational one, a cosmic censorship that ensures there are regions of reality we will never be able to observe or understand. The story of this ultimate frontier begins with the finite age of our universe and the finite speed of light. Our cosmos is approximately 13.8 billion years old, which means that light from the most distant objects has had 13.8 billion years to travel toward us. But here's where the story becomes more complex and more unsettling. Due to the expansion of space itself, the edge of our observable universe lies not 13.8 billion light-years away, but approximately 46.5 billion light-years in every direction. This apparent contradiction arises because space itself has been expanding during the time that ancient light has been travelling toward us. The galaxies that emitted the most distant light we can observe have been carried away from us by cosmic expansion, stretching the space between us even as their light journeys across the void. By the time their ancient photons reach our telescopes, the sources themselves lie at distances that light could never cross in the current age of the universe. What makes the edge of the observable universe so profoundly unsettling is not what we can see there, but what we cannot. Beyond this cosmic horizon lies more universe, possibly infinite in extent, filled with galaxies and stars and perhaps forms of matter and energy we cannot imagine. There may be other intelligent civilizations out there, entire galactic empires, cosmic phenomena that dwarf anything in our observable region, but they are forever cut off from us by the fundamental limitations of light speed and cosmic age. The edge represents the ultimate cosmic loneliness. No matter how advanced our technology becomes, no matter how sophisticated our instruments, we will never be able to observe what lies beyond this boundary. The expansion of space ensures that distant regions are receding from us faster than light itself can travel, creating an information barrier that no signal can cross. Even more unsettling is the knowledge that this boundary is not static. As time passes and the universe continues to expand, galaxies that are currently visible to us will eventually disappear beyond the cosmic horizon. The observable universe is actually shrinking in terms of the number of galaxies it contains. We are living in a cosmic golden age, a brief moment when the maximum number of galaxies are visible to us. Future civilizations will inhabit a darker, lonelier universe, where fewer and fewer distant objects remain observable. This cosmic isolation becomes even more profound when we consider the ultimate fate of our observable universe. As space continues to expand and accelerate, driven by the mysterious force we call dark energy, the galaxies we can currently see will gradually fade from view. Eventually, billions of years in the future, observers in our galaxy will see a universe that appears to contain only our local group of galaxies, with everything else having disappeared beyond the cosmic horizon. The edge of the observable universe forces us to confront the most fundamental limitations of knowledge itself. There are questions about the nature of reality that we can never answer, not because we lack the intelligence or technology, but because the answers lie forever beyond our reach. We cannot know whether the universe is finite or infinite. We cannot know what lies beyond our cosmic horizon. We cannot know whether other regions of space operate according to different physical laws or contain forms of matter and energy that exist nowhere in our observable region. This uncertainty extends to some of the most profound questions we can ask about existence. Are we alone in the universe? The honest answer is that we cannot know, because any civilizations that might exist beyond our cosmic horizon are forever invisible to us. They could be building galactic empires, could have mastered technologies we cannot imagine, could be trying to communicate across the cosmic void, and we would never know. The edge of the observable universe represents the ultimate humbling of human ambition and curiosity. We are a species that has always pushed against boundaries, that has explored every continent and ocean, that has sent probes to the edge of our solar system and beyond. But here is a boundary we can never cross, a limit we can never overcome. It is written into the very structure of space-time itself, a cosmic law that ensures there will always be more universe than we can ever observe. Perhaps most unsettling of all is the possibility that the regions beyond our cosmic horizon might operate according to different rules entirely. The laws of physics as we know them might be local phenomena, applicable only to our observable patch of the cosmos. Beyond the edge, there might be regions where different forces dominate, where matter behaves in ways we cannot imagine, where the very concepts of space and time take on meanings we cannot comprehend. The edge of the observable universe reminds us that, for all our scientific achievements, we remain cosmic prisoners, trapped within a sphere of observability beyond which we can never venture. We can send signals into the cosmic dark, but we can never know if they reach anyone. We can ask questions about the nature of reality, but we can never be certain our answers apply beyond our own cosmic neighborhood. Tonight, as we reach the end of our journey through the universe's most haunting places, the edge of the observable universe serves as the ultimate reminder of our cosmic limitations. It is not just a boundary in space, but a boundary of knowledge itself, a cosmic censorship that ensures the universe will always hold secrets beyond our reach. Somewhere out there, beyond the edge of everything we can ever know, reality continues. Galaxies form and evolve, stars are born and die, and perhaps other conscious beings wonder about the nature of existence, just as we do. But they are forever cut off from us, existing in regions of spacetime that no signal can cross, no telescope can observe, no theory can describe. The edge of the observable universe is the most terrifying place in the cosmos, precisely because it is not a place at all, but an absence, a boundary beyond which everything we care about, everything we can ever know or hope to understand, simply ceases to have meaning. It is the ultimate cosmic unknown, the final frontier that can never be crossed, the reminder that no matter how far we travel in our understanding of the universe, there will always be infinitely more that lies forever beyond our reach. As we float here in our small corner of the observable cosmos, surrounded by these cosmic terrors and mysteries, we are reminded that the universe is not just vast beyond our comprehension, but unknowable beyond our imagination. And perhaps in that unknowability lies both the greatest terror and the greatest wonder of our cosmic existence. And so, we arrive at perhaps the most unsettling realization of all. After drifting through cosmic voids that stretch beyond imagination, after contemplating invisible forces that pull entire galaxies through space, after peering into the hearts of black holes where reality itself breaks down, we come to understand that the universe's most terrifying quality isn't its violence or its emptiness or even its vast unknowable distances. It's the quiet, patient way it reminds us that we are not separate from these cosmic horrors, we are part of them. Every atom in your body was forged in the nuclear furnace of a star that died billions of years ago. The calcium in your bones, the iron in your blood, the oxygen you breathe as you listen to these words, all of it was once part of stellar cores that collapsed with unimaginable violence, creating the very elements that now make up your physical being. You are, quite literally, made of cosmic catastrophe. The water in your cells has journeyed through space for eons, perhaps passing through the tails of comets, the atmospheres of distant worlds, the accretion disks of black holes. Every breath you take connects you to the vast cosmic web, to processes that span light years and operate on timescales that dwarf human civilization. You are not observing the universe from some safe external vantage point. You are the universe observing itself. This realization brings with it a particular kind of vertigo, a cosmic perspective that can be both liberating and deeply unsettling. When you look up at the night sky, you're not just seeing distant lights scattered across the darkness. You're seeing your own deep history written in stellar fire. Those stars created the elements that eventually became your world, your body, your consciousness. The light touching your eyes has travelled across vast emptiness to reach you, carrying information about cosmic events that shaped the very possibility of your existence. But this cosmic connection comes with a price. If we are part of the universe, then we are also subject to its whims, its violence, its fundamental indifference to individual existence. The same forces that created us operate without regard for our comfort or survival. Supernovas that forge heavy elements also sterilize entire regions of space. Black holes that anchor galaxies and make cosmic structure possible can also devour solar systems without a moment's hesitation. The magnetars we discussed, with their impossibly powerful magnetic fields, represent the universe's capacity for creating conditions so extreme they challenge the very foundations of physics. Yet these same violent processes, playing out across cosmic time, helped create the heavy elements necessary for rocky planets, for complex chemistry, for life itself. The universe builds its most beautiful structures around its most terrifying objects, weaving creation and destruction into a single, incomprehensible tapestry. Consider the cosmic microwave background, that gentle afterglow of the Big Bang that still bathes everything in its ancient light. It seems so peaceful, so uniform, like a cosmic lullaby humming through space. But this faint radiation is the echo of the most violent event in the history of existence, the explosive birth of space-time itself. We live inside the aftermath of an explosion so powerful, it created not just matter and energy, but the very concepts of space and time. Even our position in the galaxy reflects this strange marriage of cosmic terror and cosmic nurture. We orbit our sun at just the right distance to maintain liquid water in a solar system located in what astronomers call the galactic habitable zone. Too close to the galactic center, and we would be sterilized by radiation from Sagittarius A hubs and the dense population of massive stars. Too far out, and the heavy elements necessary for rocky planets and complex chemistry would be too scarce to support life. But this cosmic Goldilocks zone isn't a guarantee of safety. It's simply a temporary refuge in a universe that operates according to its own vast logic. Our sun will eventually exhaust its nuclear fuel and expand into a red giant, boiling away our oceans and scorching our world. Our galaxy will collide with Andromeda in about 4.5 billion years, disrupting stellar orbits and potentially flinging our solar system into the intergalactic void. On even longer timescales, the accelerating expansion of space will carry distant galaxies beyond our cosmic horizon, leaving us in an increasingly dark and lonely universe. These aren't distant, theoretical threats. They are the inevitable consequences of living in a dynamic, evolving cosmos. The same processes that made life possible ensure that it cannot persist forever in its current form. The universe gives and takes with equal indifference, creating pockets of complexity and consciousness only to eventually reclaim them for entropy and expansion. Yet there's something oddly comforting about this cosmic perspective. Your worries about tomorrow's responsibilities, about social anxieties and career concerns, about all the small dramas that fill our daily lives, these concerns exist against the backdrop of forces so vast and indifferent they render our problems beautifully, preciously insignificant. Not unimportant, but small in a way that can be liberating. The Boötes void, that great cosmic emptiness we explored earlier, reminds us that the default state of the universe is not bustling activity, but profound silence. For every region of space filled with stars and planets, and the possibility of life, there are vast spheres of near-nothingness where nothing ever happens, where nothing ever has happened, where nothing ever will happen. The fact that we exist at all, that matter managed to organize itself into complexity and consciousness, represents a temporary victory against the universe's apparent preference for emptiness and entropy. This perspective doesn't diminish the value of human existence or human concerns. If anything, it enhances them. In a cosmos where most of space is empty and most of matter is dark and cold, the emergence of warmth and consciousness and love represents something genuinely miraculous. Every human relationship, every moment of beauty, every act of kindness or creativity stands as a small but precious rebellion against cosmic indifference. The rogue black holes wandering through our galaxy, invisible and unpredictable, serve as perfect metaphors for the fundamental uncertainty that underlies all existence. We cannot know what cosmic catastrophes might await us, what invisible forces might be heading our way, what fundamental changes to reality itself might be unfolding beyond our ability to observe or predict. But this uncertainty, rather than paralyzing us, can inspire us to appreciate the improbable gift of our current existence. We live in what cosmologists call the stelliferous era, the age of stars, when nuclear fusion lights up the cosmos and makes complex chemistry possible. This era will last for trillions of years, but it will eventually end as stars exhaust their fuel and the universe grows darker and colder. We exist during the universe's brief moment of maximum creativity, when matter and energy dance together in configurations complex enough to produce planets and life and consciousness. The quasars burning with the brightness of a trillion suns remind us that the universe was once a far more violent and chaotic place. Those hyperluminous beacons shine from the cosmic past when galaxies were still forming and supermassive black holes fed with unprecedented veracity. We live in a calmer epoch, when the universe has settled into more predictable patterns, when stable solar systems and long-lived civilizations become possible. But even this cosmic peace is temporary. The dark flow, that mysterious current pulling galaxy clusters toward unknown destinations, suggests that large-scale changes are still unfolding, that the universe continues to evolve in ways we don't fully understand. We're not living in a static cosmos, but in one that continues to surprise us, to reveal new mysteries, to challenge our understanding of what's possible. The edge of the observable universe, that ultimate boundary beyond which we can never see, serves as a constant reminder that reality extends far beyond our ability to comprehend it. There are galaxies out there, perhaps infinite in number, that we will never observe. There may be other forms of matter and energy, other laws of physics, other types of consciousness that exist beyond our cosmic horizon. We are cosmically provincial, trapped within our local patch of space-time, forever wondering about the vast unknowns that surround us. Yet this limitation, rather than diminishing us, makes our achievements all the more remarkable. Despite being confined to a tiny planet orbiting an ordinary star in an unremarkable galaxy, we have managed to map the large-scale structure of the cosmos, to peer back in time to the universe's earliest moments, to understand the nuclear processes that power stars and the gravitational dynamics that shape galaxies. We have become the universe's way of understanding itself, at least within our local cosmic neighborhood. The Magnetars with their impossibly twisted magnetic fields, the supervoids with their mysterious connections to cold spots in the cosmic microwave background, the great Attractor pulling us toward unknown destinations, all of these cosmic phenomena remind us that the universe operates according to physics that push against the very boundaries of what we thought was possible. Reality is stranger, more extreme, more beautiful and terrifying than we ever imagined, and we are part of this strangeness. The electromagnetic fields in our nervous systems, weak as they are, connect us to the same fundamental forces that create magnetars. The gravitational field that keeps our feet on the ground links us to the same force that powers black holes and shapes the cosmic web. The nuclear processes that warm our planet are cousins to the fusion fires that light up stars and the explosive nucleosynthesis that creates heavy elements in supernovas. We are not separate from the cosmic terror and cosmic beauty that surrounds us. We are expressions of it, temporary arrangements of matter and energy that have learned to contemplate their own cosmic context. In our consciousness, the universe has developed the ability to marvel at its own vast strangeness, to feel awe at its own terrible beauty, to ask questions about its own fundamental nature. Tonight, as you drift towards sleep, remember that you carry within yourself the story of cosmic evolution. Your existence represents a chain of improbable events stretching back to the Big Bang itself. The elements in your body were forged in stellar cores, scattered by supernovas, gathered by gravity into new solar systems, assembled into planets, organized into complex chemistry, and eventually arranged into the miracle of conscious awareness. You are a temporary eddy in the cosmic flow, a brief arrangement of matter that has learned to think and feel and wonder. The same universe that creates black holes and magnetars and vast empty voids has also created you, with your capacity for love and curiosity and the ability to find beauty even in cosmic terror. The universe may be vast and strange and filled with forces that dwarf human understanding, but it has also produced consciousness capable of appreciating that vastness and strangeness. In contemplating the cosmic abyss, we are not diminished but enlarged, not terrified but awed, not separated but connected to the deepest mysteries of existence. As we float here in our small corner of the cosmos, surrounded by invisible forces and unknowable distances, we can take comfort in the knowledge that we are not just observers of the universe's terrible beauty, but participants in it. We are the universe becoming aware of itself, matter organized into consciousness, cosmic evolution, taking a moment to admire its own handiwork. The void may be vast, the forces immense, the timescales incomprehensible, but consciousness has emerged nonetheless, like a flower blooming in the cosmic desert. And in that emergence, in the simple fact of your ability to wonder about these things, lies perhaps the most beautiful and improbable miracle the universe has yet produced. So rest well tonight, knowing that you are made of stars, that you carry within yourself the deep history of cosmic evolution, that your existence represents a temporary but precious victory of complexity over entropy, of consciousness over the vast, indifferent darkness. You are the universe dreaming about itself, and in your dreams, all the cosmic terror and beauty we've explored tonight will continue their ancient dance among the stars. As we drift toward the end of our cosmic journey, let me share with you one final truth that perhaps encompasses all the terror and wonder we've explored tonight. The universe, for all its vast emptiness and violent extremes, has somehow managed to create something even more mysterious than black holes or cosmic voids, or invisible attractors pulling galaxies through space. It has created you. Think about this for a moment as you settle into the quiet comfort of wherever you are tonight. Every conscious thought you have, every emotion you feel, every memory you cherish represents something the universe has never done before in exactly the same way. Your particular arrangement of atoms, your specific pattern of neural connections, your unique perspective on existence, all of it is a cosmic experiment that has never been tried before and will never be repeated exactly again. The atoms that make up your brain were once scattered across the cosmos, drifting through the cold vacuum of space, or burning in the cores of distant stars. Somehow, through processes we still don't fully understand, these particles found their way to Earth, became part of living systems, and eventually organized themselves into a structure capable of contemplating the very cosmos from which they came. You are quite literally the universe thinking about itself. but consciousness brings with it a particular kind of cosmic vertigo. To be aware in a universe filled with such vast scales and violent forces is to experience a unique form of existential weight. We are the only known arrangement of matter that worries about meaning, that feels small in the face of infinity, that can be simultaneously awed and terrified by the same cosmic phenomena. When you look up at the night sky and feel that familiar tug of wonder mixed with unease, you're experiencing something that may be genuinely unique in our cosmic neighborhood. The stars burning overhead don't contemplate their own existence. The planets orbiting distant suns don't wrestle with questions of purpose or meaning. Only we, as far as we know, have developed the capacity to feel both connected to and isolated from the cosmos that created us. This consciousness comes with responsibilities and privileges that are both beautiful and burdensome. We are the universe's memory keepers, the only known entities capable of preserving and sharing the stories written in starlight and cosmic time. Every scientific discovery, every moment of wonder, every attempt to understand our place in the cosmos represents the universe coming to know itself through us. Yet we are also acutely aware of our limitations, our fragility, our temporary nature. We know that our sun will eventually die, that our galaxy will merge with others, that the universe itself may be heading toward a heat death so complete that no trace of our existence will remain. This knowledge of our own cosmic impermanence adds a poignant beauty to every moment of consciousness, every relationship, every creative act. The same universe that produces magnetars capable of tearing apart atoms also produces the gentle electrical patterns in your brain that allow you to feel love, to appreciate beauty, to wonder about meaning. The same cosmic forces that create vast emptinesses, spanning hundreds of millions of light years, also somehow give rise to the intimate warmth of human connection, the quiet joy of a shared moment, the deep satisfaction of understanding something new about how reality works. Perhaps this is the most profound mystery we've encountered tonight. Not the great attractor or the Quasars void or the edge of the observable universe, but the simple fact that matter can organize itself into patterns capable of caring about these things. In a cosmos that operates mostly through blind physical forces, consciousness represents something genuinely extraordinary, a local violation of cosmic indifference. We exist in the narrow band between the very small and the very large, between the quantum realm, where particles behave according to probability, and the cosmic scale, where gravity shapes the architecture of space-time itself. Our bodies operate at just the right temperature for complex chemistry, on a planet located at just the right distance from a star of just the right size, in a galaxy positioned at just the right location to avoid the worst cosmic violence. This might seem like an extraordinary series of coincidences, and perhaps it is, but it's also possible that consciousness emerges wherever conditions allow, that the universe has an inherent tendency toward complexity and awareness. If so, then we may not be as alone as we sometimes feel. Somewhere among those distant galaxies, beyond the reach of our telescopes, other arrangements of matter may be contemplating their own cosmic context, feeling their own version of wonder and terror at the vast strangeness that surrounds them. The thought that consciousness might be scattered throughout the cosmos like islands of awareness in an ocean of unconscious matter is both comforting and deeply moving. It suggests that the universe's capacity for self-reflection is not limited to our small corner of existence, that the questions we ask about meaning and purpose and our place in the cosmic order might be echoing across vast distances in forms we cannot imagine. But even if we are alone, even if consciousness is a rare and precious accident that occurs only under the most specific conditions, that doesn't diminish its significance. If anything, it makes every moment of awareness more valuable, every human connection more precious, every attempt to understand and appreciate the cosmos more meaningful. The universe has spent billions of years setting the stage for this moment, right now, when you can pause in your daily existence and contemplate forces and distances that dwarf everything in your immediate experience. The supernovas that forged the elements in your body, the gravitational collapse that formed our solar system, the long evolutionary process that led to consciousness, all of it has culminated in this quiet moment of cosmic reflection. You are the universe pausing to admire its own handiwork, matter taking a moment to appreciate the vast dance of which it is a part. In your wonder at black holes and cosmic voids, in your awe at the scales and forces we've explored tonight, the cosmos is experiencing something like cosmic self-awareness, reality contemplating its own deepest mysteries through the temporary arrangement of particles that happens to be you. This perspective doesn't solve the fundamental questions about existence or eliminate the cosmic anxieties that come with awareness of our place in such a vast and indifferent universe. But it does suggest that consciousness, however temporary and fragile it might be, represents something genuinely significant in the cosmic story. We are not just passive observers of cosmic evolution, but active participants in it, the universe's way of coming to understand itself. As you drift towards sleep tonight, carrying with you images of cosmic voids and wandering black holes, of invisible forces and unknowable distances, remember that you are both infinitesimally small and profoundly significant. Small in the sense that your physical presence barely registers on cosmic scales, but significant in that you represent something the universe has achieved that may be genuinely rare and precious. You are a temporary victory of organization over entropy, of consciousness over unconsciousness, of meaning-making over meaninglessness. In a cosmos that could have remained forever dark and empty, matter has learned to light itself from within, to ask questions about its own nature, to feel awe at its own vast complexity. The cosmic terrors we've explored tonight, the places where reality breaks down or stretches beyond comprehension, they remain out there in the darkness, patient and eternal, but they are balanced by something equally extraordinary. The emergence of awareness itself, the universe's capacity to know and appreciate its own terrible beauty through arrangements of matter like you. So rest well, knowing that in your consciousness, the cosmos has achieved something remarkable. You are the universe dreaming about itself, and in those dreams, all the wonder and terror of existence finds its meaning. The void may be vast and the forces immense, but consciousness has emerged nonetheless like a candle flame flickering in the cosmic darkness. Small but precious, temporary but significant, a brief moment when the universe opens its eyes and marvels at what it has become. Tomorrow you'll wake to the gentle light of our ordinary star, to the familiar pull of our planet's gravity, to the comfortable rhythms of human existence. But tonight, as you settle into sleep, you carry within yourself the deep knowledge of cosmic strangeness, the awareness that you are part of something far larger and more mysterious than the boundaries of daily life can contain. Sweet dreams, fellow traveller. The universe is vast and strange and filled with wonders and terrors beyond imagination, but it has also created you, with your capacity for consciousness and wonder and the ability to find beauty even in cosmic darkness. And perhaps in the end, that is the most remarkable mystery of all. And so, dear traveller, we find ourselves at the end of our gentle journey through the cosmos's most haunting places. We've drifted through voids so empty they challenge our understanding of existence itself, felt the invisible pull of forces that reshape galaxies, and peered into the hearts of objects where the very laws of physics surrender to something far more mysterious. We've seen that the universe is not just vast beyond our comprehension, but filled with phenomena that operate at the very edges of what reality allows. From the patient emptiness of the Bota's void to the violent magnificence of quasars burning with the light of 1 trillion suns. From the invisible wanderers that drift through our galaxy like cosmic ghosts to the ultimate boundary beyond which we can never see, the cosmos reveals itself as a place of both terrible beauty and beautiful terror. But perhaps the most profound discovery of our journey is this: we are not separate from these cosmic mysteries, we are part of them. Every atom in your body carries the signature of stellar violence. Every breath connects you to processes that span light years. Every thought represents the universe's ongoing attempt to understand itself through the miracle of consciousness. The Magnetars with their twisted magnetic fields, the rogue black holes wandering invisibly through space, the dark flow pulling vast structures toward unknown destinations. All of these remind us that we live in a cosmos far stranger and more dynamic than our everyday experience suggests. Yet somehow, in the midst of all this cosmic extremity, matter has learned to organize itself into patterns capable of wonder, of fear, of love, of the very contemplation that has guided our journey tonight. As you settle into sleep, remember that you carry within yourself the deep history of the universe. You are made of elements forged in the nuclear furnaces of dying stars, assembled through gravitational processes that took billions of years to unfold, organized into the improbable miracle of conscious awareness. You are, quite literally, the cosmos contemplating its own vast strangeness. The voids may be empty, the forces invisible, the distances incomprehensible, but consciousness has emerged nonetheless. In your ability to wonder about these things, to feel both awed and unsettled by cosmic mystery, the universe has achieved something genuinely remarkable. You are not just an observer of reality, but an active participant in its ongoing evolution toward greater complexity and awareness. So sleep peacefully tonight, knowing that while the cosmos may be filled with forces beyond our control and mysteries beyond our understanding, it has also produced something precious and rare: the capacity for consciousness to appreciate its own cosmic context. You are the universe dreaming about itself, and in those dreams, all the terror and wonder we've explored finds its deepest meaning. The great Attractor continues its invisible work, pulling us toward unknown destinations. The cosmic voids stretch their patient emptiness across hundreds of millions of light years. The edge of the observable universe maintains its eternal silence about what lies beyond. But here, in this small corner of existence, consciousness flickers like a candle flame in the cosmic darkness, temporary but precious, fleeting but significant. Thank you for joining me on this quiet voyage through the universe's most mysterious places. If you found comfort or wonder in these cosmic contemplations, I'd be ever so grateful if you shared this journey with others who might appreciate a gentle exploration of the vast unknown. There's something beautiful about sharing our cosmic perspective, about reminding each other that we're all passengers on the same small world, drifting together through a universe far stranger and more magnificent than we ever dared imagine. Until we meet again in this peaceful corner of the cosmos, rest well, dream deeply, and remember that you are both infinitesimally small and profoundly significant in the grand story of existence. The universe may be vast and filled with terrors beyond comprehension, but it has also created you, with your capacity for wonder and your ability to find beauty even in cosmic darkness. And perhaps that is the most comforting thought of all. For in a universe that could have remained forever silent and empty, something has learned to speak, to wonder, to reach across the vast distances with curiosity and awe. You are proof that matter can organize itself into patterns capable of love, of creativity, of the gentle contemplation that has carried us through this night's journey together. The cosmic horrors we've explored tonight will continue their patient work long after we're gone. The voids will maintain their emptiness. The black holes will continue their feeding. The invisible forces will pull galaxies through space with the same quiet persistence they've shown for billions of years. But consciousness, however, brief its flickering, has added something new to the cosmic story. In your awareness of these mysteries, the universe has developed the capacity to be moved by its own terrible beauty. There's something deeply poetic about this. The same physical processes that create neutron stars and bend space-time have also created the neural networks in your brain that allow you to appreciate poetry, to feel wonder at a sunset, to experience the gentle melancholy that comes with contemplating our place in such a vast and indifferent cosmos. The universe has learned to feel through us, to know itself through our questioning, to find meaning in its own apparent meaninglessness through our persistent search for understanding. This doesn't diminish the genuine terror of cosmic scales and cosmic violence. The knowledge that we live in a galaxy with a supermassive black hole at its heart, that invisible monsters wander through space, that vast regions of emptiness stretch beyond all comprehension. This knowledge carries with it a particular weight, but it's balanced by the recognition that consciousness itself represents something genuinely miraculous, a local victory of complexity and awareness over the cosmic tendency toward simplicity and silence. As you lie there tonight, perhaps feeling both small and significant in equal measure, remember that your existence represents an extraordinary confluence of cosmic circumstances. The right star, the right planet, the right distance, the right chemistry, the right evolutionary history, all of it coming together to produce this moment of quiet reflection on the nature of existence itself. Your thoughts about black holes and cosmic voids, your sense of wonder and unease at the scales we've contemplated, these represent the universe thinking about itself through the temporary arrangement of particles that happens to be you. In your consciousness, matter has achieved something that may be genuinely rare in our cosmic neighborhood, the ability to step back and marvel at the vast dance of which it is a part. The great nothing continues its patient emptiness, but it has also somehow given rise to minds capable of contemplating that emptiness and finding in it both terror and strange beauty. The invisible forces continue their work of reshaping cosmic architecture, but they have also shaped the conditions that allow consciousness to emerge and wonder about its own cosmic context. Perhaps this is what makes us human in the deepest sense, this capacity to feel both connected to and alienated from the cosmos that created us. We are cosmic citizens, but also cosmic strangers, at home in the universe that made us but unsettled by its vast indifference to our individual fates. This tension between belonging and estrangement may be one of the defining characteristics of conscious existence, but there's beauty in this tension too. It drives us to reach beyond ourselves, to build telescopes that peer into cosmic distances, to ask questions that stretch our understanding, to create art and music and stories that help us process the overwhelming reality of our cosmic situation. Consciousness doesn't just observe the universe, it responds to it, creating meaning and beauty and connection in the face of cosmic silence. Tonight, as the universe continues its ancient dance of matter and energy across incomprehensible distances, you can rest knowing that you're both witness to and participant in something genuinely extraordinary. The cosmic terror is real, the scales genuinely overwhelming, the forces truly beyond our control, but consciousness has emerged nonetheless like a flower blooming in the cosmic desert, temporary but precious, fragile but significant. So sleep gently, fellow traveller, knowing that in your dreams, the universe continues its long conversation with itself about the nature of existence, the meaning of consciousness, and the strange beauty that emerges when matter learns to contemplate its own cosmic origins. You are the universe's way of experiencing wonder, and in that wonder lies perhaps the most profound mystery we've encountered tonight. The darkness may be vast and filled with forces beyond our comprehension, but it has also learned to dream through us, to question itself through our curiosity, to find beauty in its own terrible majesty through our capacity for awe. And in that recognition lies both comfort and cosmic responsibility, the knowledge that we are not just passengers on this cosmic journey, but active participants in the universe's ongoing attempt to understand itself. Rest well, knowing that tomorrow you'll wake to the same gentle star that has warmed our world for billions of years, on the same small planet that has nurtured consciousness into existence, in the same vast cosmos that continues to surprise us with its capacity for both terror and wonder. The mysteries will still be there, patient and eternal, waiting for curious minds to contemplate their depths and find in them both humility and inspiration. The cosmic mysteries we've explored tonight will outlast us all, but they will not outlast the questions we've learned to ask about them. Somewhere in the future, perhaps on worlds we cannot imagine orbiting stars not yet born, other conscious beings may look up at their own night sky and feel the same mixture of wonder and unease we've shared tonight. They too may discover voids that stretch beyond comprehension, forces that operate invisibly across cosmic distances, boundaries beyond which even light cannot escape, and perhaps they too will come to the same beautiful, terrifying realization that has guided our journey tonight, that consciousness is not separate from the cosmos, but part of it, not a passive observer of cosmic violence, but an active participant in the universe's ongoing attempt to understand its own nature. In their wonder at the vast darkness, in their questions about meaning and purpose, in their capacity to feel both small and significant in the face of infinity, the cosmos will continue its ancient conversation with itself. This continuity of curiosity across cosmic time offers a kind of comfort. The individual arrangements of matter that we call ourselves may be temporary, but the questions we ask, the wonder we feel, the search for understanding and meaning, these may be as fundamental to the universe as gravity or electromagnetism. Consciousness may emerge wherever conditions allow, like flowers blooming in cosmic spring, each one a unique expression of the universe's capacity for self-reflection. But for now, in this moment, in this quiet corner of space and time, it is enough to rest in the knowledge that we have been part of something larger than ourselves. We have contemplated forces that dwarf human understanding, distances that stretch beyond imagination, timescales that make our lives seem like brief flickers in the cosmic night. Yet we have done so with minds capable of finding beauty in terror, meaning in mystery, connection in the face of cosmic loneliness. The Eridanus Supervoid continues its billion-light-year emptiness, but it has also somehow given rise to minds capable of discovering it and marvelling at its implications. The great Attractor continues pulling us toward unknown destinations, but it does so in a universe that has learned to map its influence and wonder about its nature. The edge of the observable universe maintains its eternal silence, but consciousness has emerged to ask what lies beyond and to find in that unknowability both humility and inspiration. As you drift towards sleep tonight, remember that you carry within yourself the story of cosmic evolution, from the first moments after the Big Bang to this present instant when matter has learned to contemplate its own origins. You are a temporary arrangement of particles that has achieved something remarkable, the ability to step back from immediate existence and consider the vast context in which that existence unfolds. In your consciousness, hydrogen atoms, forged in the first few minutes of cosmic time, have learned to wonder about their own creation. Carbon and oxygen and iron, scattered by dying stars across billions of years, have organized themselves into patterns capable of feeling awe at the very processes that created them. The electromagnetic forces that shape atoms and molecules have given rise to neural networks that can contemplate electromagnetism itself. This recursive nature of cosmic awareness, matter studying matter, consciousness examining consciousness, the universe investigating itself through arrangements of its own substance, represents something genuinely profound. We are not external observers of cosmic evolution, but internal participants in it, the means by which the cosmos has developed the capacity for self-knowledge. The darkness between the stars may be vast and cold, and mostly empty, but it has also proven capable of nurturing worlds where complexity blooms, where simple elements combine into intricate patterns, where matter learns to think and feel and reach across the void with radio telescopes and space probes and gentle words shared in the quiet of night. Tonight, as cosmic forces continue their patient work across distances we can barely imagine, as black holes feed and galaxies spiral and the universe expands into ever greater emptiness, consciousness continues its own quiet work of observation and wonder. In laboratories and observatories around our world, human minds are peering deeper into cosmic mysteries, asking new questions, discovering new sources of awe and terror in the vast machinery of existence. This work will continue long after we're gone. Future generations will develop new ways of seeing, new instruments for listening to cosmic whispers, new theories for understanding the forces and phenomena we've glimpsed tonight. They will discover things that will make our current understanding seem quaint and limited, just as our knowledge would astonish the ancient observers, who first wondered about the lights moving across their sky. But the fundamental experience of consciousness confronting cosmic mystery will remain constant. The sense of being both part of something vast and separate from it, both connected to cosmic processes and alienated by their scale, both humbled by our limitations and inspired by our capacity to transcend them through understanding. These aspects of conscious existence seem likely to persist as long as matter can organize itself into patterns capable of thought. There's something deeply moving about this continuity of wonder across cosmic time. The same sense of awe that fills you as you contemplate the Bhuta's void or imagine the violence of a Magnetar flare may have been felt by the first conscious beings to emerge anywhere in the universe. It may be felt by the last conscious entities to exist before the cosmos grows too cold and diffuse to support complex thought. This shared experience of cosmic wonder creates a kind of community across space and time, a fellowship of conscious beings united by their capacity to feel both terror and beauty in the face of existence itself. We may be separated by vast distances and eons of time, but we are connected by our common inheritance of consciousness, our shared ability to look up at the night sky and feel moved by its terrible majesty. So as you rest tonight, knowing that tomorrow will bring you back to the familiar rhythms of earthly existence, remember that you have been part of something larger and stranger than daily life usually allows us to contemplate. You have touched, however briefly, the deepest mysteries of existence, felt the weight of cosmic scales, glimpsed the terrible beauty that emerges when matter learns to contemplate its own nature. The universe may be vast and filled with forces beyond our comprehension, but it has also created you, with your capacity for wonder and terror and the gentle melancholy that comes with knowing our place in something so much larger than ourselves. In your consciousness, the cosmos has achieved something genuinely remarkable, the ability to feel moved by its own existence, and perhaps that is enough. Perhaps the emergence of consciousness, however brief and fragile it might be on cosmic timescales, represents the universe's greatest achievement. In your ability to wonder about black holes and cosmic voids, to feel both small and significant in the face of infinity, matter has transcended its apparent limitations and achieved something approaching the miraculous. Sleep well, fellow traveller. knowing that in your dreams, the universe continues its ancient dialogue with itself about the nature of existence, the meaning of consciousness, and the strange beauty that emerges when cosmic forces learn to contemplate their own terrible majesty. You are both audience and actor in this cosmic drama, both observer and participant in the universe's ongoing attempt to understand itself. The great nothing stretches across its hundreds of millions of light years, patient and empty and magnificent in its vastness. The invisible forces continue their work of reshaping cosmic architecture with the same quiet persistence they have shown for billions of years. The wandering black holes drift through their dark trajectories, carrying with them the power to end worlds or birth new ones. But consciousness has emerged nonetheless like a candle flame flickering in the cosmic wind, small but precious, temporary but significant. And in that emergence, in your capacity to feel wonder and terror and deep connection to mysteries that dwarf human understanding, the universe has written a new chapter in its own story, one where matter learns to marvel at its own vast dance across the darkness. Rest now, cosmic citizen, knowing that you are both infinitesimally small and profoundly significant, both temporary and eternal, both alone and deeply connected to everything that has ever been or ever will be. The universe may be stranger and more terrible than we can imagine, but it has also proven capable of creating minds that can appreciate that strangeness, hearts that can be moved by cosmic beauty, and consciousness that can find meaning in the very meaninglessness of existence itself. Sweet dreams, and may you wake tomorrow with renewed wonder at the privilege of being conscious in such a vast and mysterious cosmos. The darkness may be immense, but it has learned to dream through us, and in our dreams, all the terror and beauty of existence finds its deepest expression.